everyone. I hope you are doing great today. My name is Miss Sonia Kluchinelu. I'm the chemistry teacher SS2. Our topic today is electrolysis. I repeat, electrolysis, week 2. By the end of the lesson, at least 75% of the students should be able to know the terminologies in electrolysis and also about the anodic half reaction and cathodic half reaction. Terminologies in electrolysis. First of all, we are going to start with the term electrolysis. Electrolysis is the chemical decomposition of a substance, either in molten or solution, by passing electric current through it. Okay, from this term that I just defined, the things required in electrolysis are: 1, there must be electrical current. Then 2, the substance must be in molten or solution. That leads us to the next term, electrolyte. An electrolyte is a compound or a substance, either in molten form or solution, that conducts electricity and decomposes in the process. Electrodes. What are electrodes? Electrodes are conductors in form of wires, rods, through which electric current enters or leaves the electrolyte. Electrodes is divided into two. One, we have the anode and the cathode. Anode is the positive electrode by which conventional current enters or electrons leave the electrolytes. Cathodes are negative electrodes by which conventional current leaves the electrolytes or by which electrons enter the electrolytes. The next one is electrolysis of acidified water. Another name for electrolysis of acidified water, is dilute tetraoxosulfate 6. The apparatus used is known as Hofmann's voltmeter. In your notes, you see the diagram. The Hofmann voltmeter is made up of 2 platinum foil electrodes. You can see it there. We have anode there, which is positive electrode, and the cathode there. Then there must be, remember I said there must be what? Power source of electricity. So you can see the battery there in the diagram. The electrolytes used is what? Dilute tetraoxosulfate 6. This will lead us to half reactions. The half reaction, before you talk about half reactions, let me remind you of our last term lessons about ionic theory, when I told you that when a substance, an electrolyte, dissolve in water, it forms ion. But the ion will scatter in different directions until there is electric source. They will lose their randomness, and all the positive ions will move over to the cathodes, and while the negative ions will move over to what? Anode. Okay, at the anode, we have positive hydrogen ion. Hydrogen will move to the cathode and has the tendency to accept electrons to form neutral hydrogen. You can see the equation there in your notes. Then at the anode, we have 2 ions. We have tetraoxosulfate 6 ion and we have the hydroxyl ion. It will lead us to know which of these ions can be what? Discharged. Remember in our last term, we talked about preferential discharge of ions. There are 3 factors that will aid in the preferential discharge of an ion. Number 1, we have the nature of the electrode. We have the concentration of the ion. Then the third one is position of the ion in the electrochemical series. There we have, in electrochemical series, we have cations and we have anions. In cations, remember the gameplay we play in the class, whereby when I told you we can remember those ones in cations using please sir call me as into lab, he can manufacture some gold. Then when you talk about anions, you recite follow some Nigeria citizen to borrow iodine ore. So this fun game helps us to remember those ions that are supposed to be in cations and those that are supposed to be in what? Anions. Okay, let's move over to our topic. When at the anode we have two ions, we have tetraoxosulfate 6 ion and hydrogen ion. So according to electrochemical series, the O hydrogen ion is below the tetraoxosulfate 6 ions in the what? In the electrochemical series. Therefore, hydrogen ion will be discharged in preference of what? Tetraoxosulfate 6 ion. I repeat, both tetraoxosulfate 6 ion, that's SO4, and hydrogen ion move to the anode, whereby hydrogen ion, being lower in electrochemical series due to its low electronegativity, is preferentially discharged and lose its electron to become neutral. Then you will see the equations in your notes. From there, at the end, what you will have is what? From hydrogen ion, when it loses electron, it's combined with another hydrogen ion to form what? Water and what? Oxygen. Now, when you talk about the summary of half reaction, the summary means you add the anodic half reactions and the cathodic half reactions. How are we going to do it? By choosing ions in the right side and the final neutral stable atom in the left side. It will end, what we are going to have after we combine it will be 4 hydrogen ion plus 4 molecules of hydrogen ion, giving us 2 molecules of water plus oxygen and what? Water. Okay, now we are going to talk about the electrolysis of what? Copper 2 tetraoxosulfate 6 using carbon electrodes. The electrodes involved are platinum. You can use platinum or carbon. Then the electrolyte there is what? Concentrated copper 2 tetraoxosulfate 6. From the diagram, there is equally electric source there. Then in half reaction, in the cathodic side of the reaction, we have copper, which is positive ion, and hydrogen, which is positive ion. They will migrate to the cathode. Copper ion, being lower in the electrochemical series, is discharged. What do I mean by discharge? Something like pouring away, will be taken away from the electrolytes. So, and whatever that is being discharged must change to what? Neutral. So there we have copper ion, because the valency, the charge of copper ion is +2, so it will require 2 electrons. It will accept, it will what? Require two electrons to become what? Neutral. Then in the anodic side, we have tetraoxosulfate 6 ion and hydrogen ion. Just like what happened in electrolysis of acidified water, that's tetraoxosulfate 6. Hydrogen ion will be discharged. In other words, at the end of the equation in your notes, what you have is what? Water and what? Oxygen molecule. Then let's move over to electrolysis of copper 2 tetraoxo sulfate 6 using copper anode. You know, the other one I explained earlier is copper 2 tetraoxo sulfate 6 using platinum or carbon anode. So you can see the difference. The other one is carbon and this one is what? Copper anode. Okay, the same electrolyte is being used, that is tetraoxo sulfate 6. But what really happened? Three things are involved when you talk about the reactions, half anodic half reactions. Three things involved are: one, we have sulfation of the anode, that the discharge of tetraoxo sulfate 6 ion. Second, the discharge of hydroxyl ion. And third, conversion of copper atom of the anode to copper ion. You can see the equations there. So what happened at the anode? Copper will be discharged to form what? Neutral copper. Then at the anode, the discharge of SO4 would, tetraoxo sulfate 6, that's SO4 ion, will give out 2 electrons to become neutral. You can see the equation there. Then the SO4 radical attack copper anode to form copper 2 tetraoxo sulfate 6. Therefore, no ions are discharged and there is no color change since copper moves from anode to cathode. Thank you. So the assignments we have for this lesson, which will be submitted at the resumption of the school, number 1, list the factors that affect the discharge of ions. Number 2, explain why the color of the electrolyte used in the electrolysis of copper 2 tetraoxo sulfate 6 using platinum anode change color.